Hey everyone, so let's get started on how to build awesome components with Angular CDK. So first of all, who am I? By day, I'm a software engineer at Momondo, where we help you open your world. And by night, I'm a team member on the Angular Material team, where we build Angular Material as well as the Angular CDK. You can find me on GitHub and on Twitter. So what is the CDK? The CDK stands for a Component Dev Kit, which is a set of robust, well-tested, flexible, and performant APIs that we've used to build Angular Material. In the past, if you've been following AngularJS, it's the core part of AngularJS, but we've pulled it out into a separate bundle, so you can reuse it without pulling out the whole package. It is written and maintained by the Material team, and we've used it to build all the components. So why should you use the CDK? You should use it because you don't want to reinvent the wheel every time that you need to build a new component. So things like positioning, accessibility, bidirectionality are all figured out for you, so you can only care about the business logic of your application. So to get started, you just have to npm install angular/cdk, and you're good to go. And if you've installed it, you'll notice that it consists of several entry points, which are the accessibility, bidirectionality, portals, overlays, some scrolling utilities, some unstyled components, then some observer utilities, some platform detection, coercion, collections, and also some testing utilities. So the way you use them is you usually just pull down the single module from the package, so you'll notice that there's a little bit of a pattern. So for example, if you want the accessibility module, say you import the accessibility module from the accessibility package, and then you add it to your imports, and you're good to go. So let's get started with the accessibility. You can see that's available under the accessibility entry point, and it includes a lot of utilities for managing the accessibility of your components. So there's things like managing focus, trapping focus, figuring out how focus made it into a component and when it makes it out. You can also check where an element is actually focusable or interactable. You can also announce text to assistive technologies and so on. So I have a little bit an example of how you can trap focus within a component. So the declarative approach is just adding the CDK trap focus attribute to the element, and this will make sure that the user's focus can't escape outside of this component. This is useful for something like a dialog, where, for example, if the user keeps tabbing, they might end up behind the dialog, which of course can be annoying for a blind user. And I have an example. Yep, once it loads. Yeah, so you can see this. I have the focus trap around this form element, and if I try tabbing through, you can see that focus just wraps around instead of going outside to the next element. The focus trap also exposes an API which lets you, for example, skip focus to the first focusable element or the last focusable element, or you can just use it to figure out which element is focusable. And if you don't have access to the template, you can also use it programmatically. You just have to use the focus trap factory, which you use just to create a focus trap and then attach it to an element. Then next up is managing focus inside of a list. So if you've built an accessible select element or a menu, you might have run into an issue where you have to move focus as the user presses down or up, and then you also have to wrap the focus around when they reach the end. Also, you have to skip disabled elements, and this is what the focus key manager handles for you. And the way that you consume the focus key manager is that you just put it in, and you instantiate it, and you have to give it a query list of the items that it's going to go through. The list manager accepts a query list, which is just the output of the content children or the view children. And then you can also tell it, for example, to wrap focus. So when you reach the end, it just jumps back to the top, or you can decide not to. You can also tell it to have a type ahead. So if you know the native select element When you press A, for example, it goes to the first element that has A, then it goes to the second element. If you press C, it just skips. So that just comes baked in. And it also has an API that lets you set focus, move focus, and so forth. Yeah, so I also have an example for this one. So this is an example of just a list that the user can tap through. So you can see that if I tap to it, the list receives focus, and once I start pressing the buttons, we just pipe those keyboard events to the key manager, and that takes care of focus and everything else for you. So you can see that it skips the disabled element, it wraps, and so on. And this is useful for things like selects, menus, any sort of as a rule. If you're using the list box role, you probably want to use this also if you're using a combo box. And we've used this, for example, we've used this to build the Angular material select and the menu and the selection list and pretty much, and the autocomplete. So it's used all over the place and it's pretty robust. So next up is the BD module or the bidirectionality. And it's useful if you're building components that are supposed to be consumed both by users that use left to right script and right to left. And it's relatively simple. It figures out what the direction of the user is and also lets you subscribe to events. And for example, you can see a slider API. So if you're building a slider, you know that it's supposed to slide from left to right. But on RTO users, it's supposed to slide from right to left. And you can use this API to figure out how you're supposed to slide the slider. So the API is just you inject the directionality service, and you can figure out just by the value. And you can also subscribe to changes in the value and react if the direction changed dynamically. And this just looks for these their attributes and looks up the DOM to figure out the inheritance. Right, so next up. So this is one of the key components of the CDK. We use it almost everywhere on Angular material, and it's the portals. So portals are, they let you render a piece of UI in another place in the DOM, and they're useful for pop-ups, for menus, for selects, for autocompleters, for pretty much everything. And a portal usually consists of a portal host and a portal. The host is just where you project your content, so it can be anything or any element. And the portals can be template portals and component portals. The difference between them is that with the template portal, you take an ng template that's provided by the user, and you project that into the host. And with the component portal, you just instantiate a new component. So user provides you with a component, and then you instantiate it for them. You add some injection tokens, and you project them into a host. So here's an example of how to consume the template portals. So this is somewhat a simplified example of how we built the material menu. So you just import the portal host directive, and you stick it somewhere in your template. That's where you want the user's content to go. So for example, our positioning works by having just an element at the end of the body that's position fixed, and we use that to position everything. So we use the portal host to take something and put it into that container element. And here's an ng template. So you can use this together with an ng content to take the user's content, wrap it in a template, and then use that to instantiate the template portal. And the way it works is that you use a view child to get the portal host, and then you also use a view child to get the template ref. And you use those to create a new template portal with the template ref, and afterwards you just attach it to the portal host. And I have a little bit of an example. Yeah, so here we have an element that's position fixed, that's positioned outside of everything else. And then in here we have an ng template. You can see that just has a button with a counter. And on demand, you can just project it in here, and data binding still works. You can also use it to project it again if you want to. So this is useful if you need to project a large amount of elements, because you can just project the same thing over and over pretty quickly. And the advantage of using this over component portals is that they share the same scope as the view that you put it in. So they share the scope of this view, that's the app component. So that means that the counter is shared between all of them.
Can you make the code bigger?
Oh, this better? Oh, there you go. So that's a quick overview of the template portals. And now we can move on to the component portals. It's pretty much the same concept, except that when you're instantiating it, you're taking a class that afterwards is going to get projected. So this is useful for things like dialogues, where you can have a service that the user just feeds it some TypeScript class, and then it takes it, instantiates it, maybe adds some injection tokens, and projects it. And the advantage of this is that every instantiated component has its own scope, which means that you can't leak variables in between them and so on. And I have a similar example, but built with the component portal. Yep, so it works the same way, but you can see now if I project another one, they have a completely separate scope. And I can show you an example of the code. Yeah, so some styling. Yeah, you can see that I have the projected content element, which gets instantiated before I inject it. One thing to keep in mind when you're using component portals is that you have to add the class that you're going to instantiate to the entry components of your app, and that's so it can be compiled with AOT. Yeah, I can show you. So if you have your main app, you just have to add projected content to the declarations and the entry components, and then it just works. So now on to overlays. Overlays are they tie in with portals, and they're what we use to position something either on top of the page or relative to an element. It's what we use for all of the menus, autocompletes, dialogues, things like that. So the way you manage an overlay is that you create one through the overlay service, and the overlay service gives you back an overlay ref, and you use the ref to attach portals to it, or detach, or dispose of it, and yeah. So the way you create an overlay ref is that you just pass in you inject the overlay service, use it to create a new overlay, and you pass in some config. So the config is pretty self-explanatory, so you tell it where it should have a backdrop, where it should have a class. But the two options that you should keep an eye on is the position strategy and the scroll strategy. We are going to get to those in a minute. Yeah, so the position strategies, they determine how your element is going to be rendered. So Angular material comes with two position strategies by default. The global position strategy, which just positions it on top of everything, which is useful for things like dialogues, notifications, and so on. And then there's a connected position strategy, which positions the element in relation to another element. So let's say you want a button that should show a drop-down. The connected position strategy positions it relative to the element, and you can give it fallback positions and so on. So how do you use a global strategy? Again, through the overlay service, you create a new position with this factory function, and you say that you want a global position, and then you can tell it to center it horizontally, vertically. You can also tell it to be at the bottom, at the top. You can also give it an offset, and then you just pass that position strategy to your overlay. And I have an example. Yeah, so for example, I have a dialog. And when I open it, you can see that it's centered horizontally, and the overlay also instantiated the portal for me and put it in the proper place. And it also renders the backdrop automatically and does the slide animation. API is pretty basic. You create the portal and you attach it to the overlay. Then you can also, for example, subscribe to clicks on the backdrop if you want that to close the element, but of course, it's not necessary. Yeah, and now we can move on to connected positions. They're the ones that position something relative to the element. They have a little bit more boilerplate, but they're more powerful because they also have fallback positions and things like that. So the way it works is that you give it a pair of positions. So you say like the origin, so the x-axis of the overlay is supposed to align with the x-axis of the trigger. So in this case, it's just going to be the left sides are going to align. And then you also tell it that the same for the y-axis. And in this case, the top of the overlay is going to align with the bottom of the button. And you can also give it the fallback position, which is, for example, if there's not enough space to open to the bottom, it's just going to flip to the top. And you can give it as many fallback positions as you want. And the connected position strategy will figure out which one to use depending on which one will show the biggest area of the element. And again, you just pass it into the position strategy. Yep, and I have an example. Yep, so here's a menu. Again, it uses the same API. And if I scroll a little bit, so it can't open to the bottom anymore, it's just going to flip to the top. Now, also, if you note, I've added some content so the page is scrollable. And you can see that if I scroll, it doesn't work so well. And this plays in with the next part of the overlays, which is scroll strategies. So scroll strategies determine what happens with your element if the user scrolls while it's open. And the CEK comes with 4 scroll strategies by default. So block, which just blocks the user from scrolling. Then there's close, which just closes as soon as the user scrolls away. There's reposition, which is going to update the position of the element while the user is scrolling. And then no up, which just doesn't do anything, which is the default scroll strategy. So how do you use it? It's the same concept. You just refer to the overlay, and then you dot your way through the scroll strategies, and you instantiate a new scroll strategy. And some of them also have some options. So for example, the reposition one, you can give it like a debounce period that it should debounce the scroll events. And I have a couple of examples. So let's say with our previous example with the dialog, now when you open it, you can't scroll the background. Then, for the reposition strategy, you can see now if I scroll down, it's actually at the proper place, and if I scroll away, it's going to update the position, which can be pretty useful. I can also show you a demo with, instead of repositioning, we can also just tell it to close. So let's say close. Yep, and now when I open it, yeah, I think it ended up throwing an error somewhere. No? Well, in theory, it should just close when you move away. On the clunker?
On the preview, there's an update button.
Okay. No, I can't see it. Oh, we can open it in the editor, or just move on. So all of these 3 APIs come together when you're building an overlay-based component. So for example, you can build a component that just takes in the user's content, use the content to create the portal, then you use that portal, then you figure out what kind of position you want, you pass it into the overlay create, and when you get the overlay rev back, you just attach it. And of course, you can add a close method which just detaches the portal, which also lets you quickly reopen it. But you have to remember that you should destroy it in the ng on destroy, otherwise it's going to hang around in memory forever. Yep. So now onto the scrolling entry point. This contains a couple of APIs that let you react to scrolling in the viewport. They manage a single scroll listener for the entire page. They let you debounce it. They also remove that scroll listener if nothing is actually listening to it. And they also let you measure the viewport and cache the value so you don't trash the viewport if you need to hit the API all the time. So for example, reacting to scrolling, it's pretty simple. You just import the scroll dispatcher service and you subscribe to the scrolled observable. And then you can use the viewport ruler to check the window size and also to check the window scroll position. And this 150 here just lets you debounce the scroll events so you don't end up doing too much because it fires for every pixel that you've scrolled. And oops. Yeah, I have an example. So it's just a regular page with some counters, so you can see by default it just updates all the time, and the bottom one is just scrolled. So yeah, and it updates eventually. So that was the scrolling. Now we can move on to the unstyled components. These are just the bare bones components of the table and the stepper. We're working on adding more components to them, and you can use them if you like the Angular material behavior, but not necessarily the material feel, which means that they come with the necessary DOM structure and logic and all that, but they don't have all of the styling and accessibility and things like that. So for example, if you want to consume the Angular material table to build your own data table that doesn't look like the material table, you can just import the CDK table module, and then your module, you consume it the same way as the Angular material table. So you just define which columns you want, you define your data source, which is just supposed to return an observable with some data. And in your view, you just use the CDK table component together with the table cell, here cell. If you use the Angular material table, the API is pretty familiar. And I have an example. Yep, so this is just a custom table that I built with the CDK. It doesn't import anything from material, and it has the exact same behavior. It also supports sorting, filtering, pretty much everything. And for example, you can see if I just remove all the custom styles that I added to it, and if it ends up updating, yeah. So you can see it's just the DOM structure, and then it's all up to you about how you're going to style it. So you could use Flexbox, you could use regular tables, you can do whatever you want. Yep, so these were the bigger APIs of the CDK, but we also have a collection of some smaller APIs that there are like 1 or 2 classes that can also be pretty useful, but aren't necessarily. They handle some very specific cases. So for example, we have the observers API. This contains a wrapper around the mutation observer, which just lets you stick a directive on an element, and it's going to dispatch an event when something on that element changes. In most cases, you won't really need the observed content, but for example, if you don't have control about what goes into your element. So for example, in material, we have the table, the tabs component, where the user can put in their own header. And for example, in that header, they can put anything, and we need to resize depending on the content inside of it. And we use this to monitor changes inside that element. So for example, if you have this data binding, usually you wouldn't have access to when this text changes. You'd have to query the DOM or do some dirty checking yourself. But with the CDK, you can just stick the element, the directive on it, and you're good to go. So I'm just tapping, and whenever this changes, the counter will update. In theory, it will also update whenever I change it through the DevTools. Then onto the coercion. So this is just a set of utilities that let you coerce some user input into the data that you expect. So for example, if you've used the native buttons disabled attribute, you know that it works like disabled, just as disabled, but you can also data bind to disabled. And this just lets you coerce that regular disabled or the data bound disabled into a Boolean. And the way you consume it, you just define a private property that just contains a proper value. You have a getter that just returns it. And before you say, whenever it gets set, you just coerce it to a Boolean. So for example, if this was undefined, it will still get coerced to a true because that's expected, but if it was a no, then it would be coerced to a false. Then the next API is the collections. This includes things like the data table's data source, as well as the selection model. So for example, the selection model is what we use for things like select to keep track of what is selected, dispatch events, so select elements, deselect elements. And the way you consume it is you just instantiate it and you tell it whether you want multiple selection or single selection. For example, in this case, we just want the single selection, so we want multiple selections, so we just pass it in true. And for free, you get this select method, which just adds to it. You get the deselect for free. Then you get this changed event. It just removes a lot of boilerplate from your code if you're building a form control. Then the platform. This is an API that you shouldn't really need to use in 2017, but you might end up having to use. It helps with browser sniffing. So for some things that you can't really feature detect, like whether SVG animations work or which edge cases, like in some browsers, an element is focusable, but not in ours. And it also exposes where you're server-side rendering or client-side. So for example, we have this fancy SVG spinner which just animates SVG. And if you try to animate SVG in IE, you know that it just doesn't work. And it sometimes works on edge. So if you want to skip that animation and fall back to something more simple, you can use this one to feature detect. And also if you're touching the DOM in some way that's not supported when you're rendering server-side, you can just check where it's on a browser. Then testing utilities. These are just utilities that we've accumulated while unit testing Angular material. They let you do things like dispatch viewport, dispatch mouse events, keyboard events, create fake events. They also let you mock out the viewport and things like that. So I have an example of how you can test some mouse down click handler on a button. So you just create your fixture, you figure out which element you need to test, and then you can just dispatch the event to the element, and you say whether it's a click, a mouse down, whatever. You can also pass in which coordinates were clicked on the element, and you detect changes. And for example, you can check in this case where the default was prevented and where something was invoked. And it also handles some like cross-browser inconsistencies when it comes to creating fake events and dispatching them. And this was sort of a quick overview. And you have just some things to remember. You can get the CDK by npm installing at angular/CDK. The CDK is currently in beta 11. We're currently working on our first RC. And the first stable version is supposed to hit the gear with Angular 5. You can follow along progress on the Angular Material 2 repo. And we also have a Google group where people help out. We also help out on Stack Overflow and so on. And there's a link to my slides out here. I also have some more advanced things that you could do with the CDK. So we have this is our Angular material demo app, where we just test out all of the various components. So for example, the select, which uses the selection model, it uses all of the accessibility utilities, it uses the connected positioning, and so forth. For example, the multiple selection, you can see, you can tap to it, open it by keyboard, and it manages keyboard focus for you. When you select an element, it pipes that to the selection model, which then dispatches the proper events, keeps track of everything, and so forth. This also uses the connected positioning with some customizations like aligning the selected item in the select with the trigger, and those are things that the CDK lets you do. Another advanced example of the connected positioning is the material menu. So for example, we have a nested menu, which you can open one overlay and then position another overlay relative to it. And you can also position another overlay relative to that. And it also lets you, again, manage focus, keyboard events, and so on. I also have an example of the global positioning. So for example, on the snack bar, this is positioned globally, and we've said that you just want it to position at the bottom 0 and then center vertically. And this instantiates this snack bar component where you can also add a retry button or whatever you want. Yeah, so this is more or less it. Any questions? Yes?
Let's just take the microphone.
Will there be docs?
We're hoping eventually. Right now we have a lot of markdown files in the repo, and one of our goals for Sable is to actually have proper docs for it. But right now the best examples are usually inside either the unit tests or the markdown files, or just the material components that are implementing the various APIs. Yep.
More questions? No? Maria will help me give you the mic. Ask while I can.
In one of your examples, you had the input decorator about the getter property, not the setter property.
Yep.
Does it matter?
No, not really. Our convention usually is just to put it so we do input, getter, setter, and I don't think Angular really cares about it. Yep.
Okay, if we don't have any more questions, let's give it up for Kristiyan for showing us how to.
Okay.